The geometric sequence is also a list of numbers. They have something called common ratio R. Let's look at an example. Suppose I give you the following list. Is this a geometric sequence? Well, let's see. What is 4 divided by 2? Do it here. 4 over 2, that's 2. How about 8 and 4? 8 over 4, that's 2. How about 16 and 8? 16 divided by 8 is also 2. So you have 2 here everywhere. So R, the common difference, is equal to 2. Suppose I give you... Okay, think about this. Is this a geometric sequence? We have to take this number divided by the number before it, see what we get. So we take negative 2 over 9 divided by 1/3, that means times 3 over 1. Remember the division, you multiply by the reciprocal, you will get negative 2 over 3. So now let's do the same thing. Let's take this number divided by this number. Let's see what we get. 4 over 27 times negative 9 over 2. Again, remember, I multiply by the reciprocal. That's how I divide fractions. So maybe I can simplify first. So 2 goes into 4 2 times, and then 9 goes into 27 3 times. So I have 2 times the negative 1, that's negative 2 over 3 times 1 over 3. See, same. They are the same. If you use the other number, you will get the same thing. So the common ratio R is equal to negative 2 over 3. So what would be the next number? Here, I will take the number before it, will be negative 8 over 81 times negative 2 over 3. So the two negatives will cancel. I will end up with 16 over 243. This is the first element. Now what is going to be element number 10? Obviously you can tell that the common ratio is what? So this number divided by this number, 3.3 divided by 1.1 is 3. So the formula says AN is equal to A1 times the common ratio to the n minus 1 power. So let's apply this formula. So I have AN, so that's A of 10, that means the 10th element of our sequence, is equal to A1. We're starting from here, A1, 1.1 times the common ratio, that's 3, the power of 10 minus 1. Again, why 10? Because I'm looking for element number 10, the 10th element. So in other words, I have 1.1 times 3 to the 9th power. So this is the 10th element in this geometric sequence. Suppose I give you now, and so forth. Well, I hope you can see that each time I'm multiplying by negative 1 over 2. Here, I hope you can see that I'm really multiplying by negative 1 over 2 each time. To go from the first number to the next, multiply 1 over 2, negative 1 over 2 times negative 1 over 2. The common ratio is negative 1/2. Now, okay, what will be our fifth element of the sequence? Again, let's use the formula and see what happens. So again, the formula is going to be A of n is equal to A1 times Rn minus 1. So A of n, that means A of 5 is equal to A of 1, which is 1 over 5, times the common ratio, negative 1 over 2 to the power of 5 minus 1. Okay, so that is 1/5 times negative 1 over 2 to the 4th power. That will be 1/5 times 1, and then of course the negative will go away. You have an even number here, so the negatives will cancel to 1 over 80, which makes sense. This is the 4th element, and when you multiply this number by negative 1 over 2, you get positive 1 over 80, which is the same answer that we got.